Now we have already discussed how to implement the model in the previous lecture. We created this model with some of these parameters like activation function, solver, which is basically an optimizer, and learning rate and iteration. After that we saw the loss, and at the 508 iteration it was able to just converge, and at that point we stopped our model and we used the same model in order to get the prediction. You can also print this Y prediction if you want to see what is the prediction that is done by the model. Now let's evaluate our model. So next thing is a evaluation of a model. So what is the evaluation? First of all, we have already made a model and we need to find whether our model is perfect or not, whether it is capable of prediction of Bayesian data or not, unknown data or not. So for that reason we need to just do this cross validation technique. So cross validation is a resampling procedure which is used to evaluate machine learning model on a limited data sample. So this is available in the limited data sample. So what this does is basically this has this technique called as k-fold cross validation, where k is given the value 10 in our project. You can see here CV is given as a 10, so that means cross validation value of cross validation is given is 10 over here. So which means that our data, our training data will be divided as in 10 cluster. So they will be divided in a 10 cluster, and now see here, let's say that we have till 10 cluster. Now at first time what is happening is basically we are going to give this one cluster, only one cluster for training, and the remaining 9 cluster for the training. So one only for the testing and remaining 9 for the training. After that, the next, after doing this, what is going to happen is again the same task is repeated for the next cluster. Now again this cluster, this only one cluster is going to be given for testing, and this remaining 9 again, this remaining 9 will be again given to the training procedure. Again this task will continue until and unless each and every are given to the training and testing. So this way we are going to evaluate the classification model by running the model over the test data. After that, creating a confusion matrix, and we calculate the accuracy and error rate of the model, and this way we are going to evaluate our model. So basically if you have a classification task, if you have a limited data sample, go with cross validation tasks. And we have this k-fold cross validation where k is to be just available here. If you want to put the value of k, that needs to be inside this parameter CV, and you need to provide the model that needs to be evaluated. You need to provide the test sample data. This is the actual data, this is a desired data. So this part is a desired data of the program, and this is the predicted data by our model, and it is going to tally this predicted data against the desired data or actual data, and it is going to do that iteration one more time. And after that we can predict the score using this matrix.accuracy score, where we put this Y test and Y prediction, and we see the score here on this 10 cross-fold cross validation. For each that is validation, we can see here we have this overall accuracy is 88%, and we can see the 10 accuracy printed right here for each of those training and testing data set. So this way we can evaluate our metrics or evaluate our program. Now next thing is to plot the confusion matrix. So what is a confusion matrix? If you remember, confusion matrix is used if we have the classification problem. If there is a classification problem, we normally print confusion matrix. So this is for the confusion matrix. We import the confusion matrix, we import the classification report also. If you want to see precision, recall and everything, we use this predict to get the prediction, and this is the array which is for this. So you need to make the array in order to put that into the confusion matrix, otherwise it might get you an error. So we create an array out of it and we put that in the confusion matrix, and after that you can clearly see we have this, that is confusion matrix. Since we have 3 classes, so that means the confusion matrix will be of the order 3 by 3, because we have the confusion matrix that is of order 3. So this way we plotted our confusion matrix. You can also see the description right given here. what is the accuracy, how the accuracy is plotted, how the precision is just plotted, or how the precision can be calculated using this confusion matrix, how the recall can be calculated, how the F1 score can be calculated, macro average, weight average. And similarly, if you want that same thing, if you want to make the computer to do the same thing, then you can print just a classification report, give the y-right is the desired, and y predicted is the prediction that is done by our model. And after that, you can see for the first class, this is the precision, for the first class, this is the precision, and this is the recall, F1 score, support, accuracy, average, everything is given here. Similarly, if you want your confusion matrix to be plotted like in an attractive way, then you can use this heat map in order to plot this, and this way you can also plot your confusion matrix. So this is all about multi-layer perceptron. So you have learned about the artificial neural network, how to make the artificial neural network. Now, one of the important thing about the artificial network is you can change these parameters. So they are called the hyperparameters. Some of these parameters like solver, like learning rate, like you can change the iteration, you can change the batch size, you can change the activation function, and so on, or you can change this number of hidden layer. So these are called the hyperparameter. And you can change this hyperparameter, you can tune this hyperparameter in order to upgrade the performance of your neural network. Just remember that you can change any of these parameters in our network and see and observe if the accuracy will increase or decrease, and we choose only those parameters with which we get the highest accuracy. So we are going to test several experiments. We are going to make several experiments and get the optimal solution in the next lecture. See you in the next one.